Okay, so we've looked at finding missing sides in triangles. What if we wanted to find an angle? All right, so let's say I've got the following information. I've got this side is 15 centimeters, and I've got the hypotenuse is 23 centimeters. And I want to know what this angle is right here. Is that enough information for me to figure that out? Well, the trig ratios need two sides. Now I've got two sides, so yes, we do have enough information to figure it out. So let's do that. Let's start this process in the same sort of way as we've done with sides. I'm going to look at the information that I've got. Well, the angle that I was after was this one here, so I'm going to call that theta. This side, the 15 centimeter side, would be its adjacent side, and the 23 centimeters, that's the hypotenuse. And so because I've got the adjacent, that's because I'm dealing with the adjacent side and the hypotenuse, that's going to be cos that I'm going to use. So looking back at our mnemonic, SOHCAHTOA, whenever we're working with the adjacent and the hypotenuse, well, that's this bit of it, and that involves the cosine ratio, the cos ratio. So I'll start by writing out the cos ratio. Cos theta equals adjacent on hypotenuse. And now I'll fill in the information that I've got. Well, theta I don't know, so I'm just going to leave that as theta. That's the thing that we're actually after here. We want to find the angle. We do know the adjacent is 15 and the hypotenuse is 23. So we've got a cos ratio of 15 over 23. What we want to do is go back from that ratio and find the angle that's associated with it. Okay, so in our previous questions, what we've been doing is starting with an angle and finding a length, starting with an angle and finding a ratio. What we're doing here is the opposite. We're starting with a ratio and working backwards to find an angle. And so what we do here, it's a little bit like squaring and square rooting. They're both opposites of one another. And we're doing the opposite of finding a ratio, we're finding an angle. And so the way we, the notation that we use here, in order to, if you can think of it in the same way as we do when we're solving equations, you need to undo something in order to get you back to your original variable that you're after. We're after theta. We know that cos theta is 15 on 23. We want theta, and so we're going to undo the cos, if you like. It's not a great way of phrasing it, but what we do is we use the opposite function, and that looks like this. And you'll see it on your calculator. You'll see a cos, so just above the cos button on your calculator is cos with a little -1 above it. And you can think of that as the opposite of finding the cos ratio. What we're doing is we're finding the angle associated with that ratio. And this is the way we write it. Theta is, and the way we say it is not cos to the -1. We're not raising cos to the -1. Cos, remember, doesn't exist on its own. Cos to the way we say this is inverse cos. Right, theta is equal to inverse cos of 15 on 23. So we're taking a ratio and we're working backwards. This is what the inverse cos does. It works backwards to find our angle. The way we put that into it, so the way we do it on a calculator, we go shift. You don't have to write this when you do it. I'm just doing it to show you the buttons you need to press. Shift cos. And then 15 on 23, so 15 divided by 23, and you might need to close some brackets, but that's basically it. And so the answer you'll get when you do that whoops, shift cos 15 divided by 23, close brackets, and you get 49.29 429, and it goes on. Okay, now what is this thing that we've got here? Remember what we were doing? We're finding an angle. So this isn't a length that I've got here, this 49, this is an angle, and so the units are degrees. Okay, that angle there can only be 49.29429 degrees. There's no other possibility. And so we could leave it like that, but more often than not, we want to write it in degrees, minutes, and seconds. So if I press the that special little degrees, minutes, and seconds button, I get 49 degrees, 17 minutes, and 39.46 seconds. Now, often in these sorts of questions, you're asked to find an angle correct to the nearest minute, or correct to the nearest second, or correct to the nearest degree. And so I'm going to round this off, because I haven't specified, I'm just going to round it off to the nearest minute. Now looking at this, it's 49 degrees, 17 minutes, and 39.46 seconds. So if you think about that in time, is it closer to 17 minutes or closer to 18 minutes? Well, it's 39 seconds past 17 minutes, so it's closer to 18 minutes. So I'm going to round that up. 49 degrees, 18 minutes, correct to the nearest minute. And that's how we find angles.